Okay, so where I was last time was working on a snapshot. So to back up a little bit more, let's see. Let's go to the repository. github.com/vrmeet.xr. I added some wiki pages. So this is about initialization, menu manager, generator. Okay, so it looks like I don't have something for creating events yet, do I? Let's see. Okay, I kind of do. Okay, so this is a little bit small, but this is kind of like the JavaScript module boot up sequence. So I changed this to be event sourcing. So you have an orchestrator JavaScript which loads up other managers, for example, the scene manager and the WebRTC manager. So there's an arrow going here to initialize and start the scene, creates the camera, that kind of stuff. It also loads the WebRTC manager to say initialize and load up some listeners. And then it loads Svelte components, which are HTML overlays. This is what shows the welcome screen, and you can click a button to say you want to enter or you want to observe. So that emits an internal message over Signal Hub, which I've left out of this diagram, but Space Broker is another piece of JavaScript, another class that's listening to this, and this thing will join the space channel. So this is what's joining the Phoenix WebSocket. At that point, we might get some presence state and presence diff. This happens because of Phoenix presence. But then at that point, I'm going to actually emit an event. So events are going to come from the front end. So before I had some versions where the events were Elixir structs, but now all events are just TypeScript objects. So we emit this event, and then in the space server, it will go and persist these events on disk. So I didn't really elaborate how it does this, so I can elaborate this a little bit more. So let me save this thing, file, save now. Let's create a new file called persisting events. So we're going to have our space channel. Let's have the space channel be the recipient. So space broker is the piece of JavaScript code that talks to a space channel. So it says it's going to push an event, and then it's going to have some payload. And I'll just get rid of this. So this says space broker pushes event to payload. So what does that look like? So we have a piece of code called space broker, and it's listening for some kind of event, and then when it receives a message of type that's in the outgoing it's one of the outgoing events. When it's of type event, it will just forward that to the space channel. So it will push a new message. The message name is event, and then the payload is the same payload except we add to it a timestamp. So for example, let's say you click on a menu to go create a primitive. So remember we had that menu, primitives menu.
Yeah.
So here is the list of things on the menu, right? Box, cone. So you can create these things, and all of these are drawn into squares that we say, here, click on one of these things. So here's the callback. So this is the code that's called when you click on one of these words. We create an event. So here's the event we want to create. So constant entity event. It's a type of event, and this is what it looks like. It has a message, which I call the M. Key M stands for message, entity created, and key of P stands for a payload. And every type of message has a particular payload. So in this case, this is probably the most complicated one because it said, I'm creating an entity. Here's the type of entity, which is a primitive, which is one of these strings, cone, sphere, grid, and it's going to have a unique ID, which here I generated a unique UUID in the front end, and then some kind of random primitive underscore random letters for the name, and then components list. And the components list is made up of position, rotation, and scaling. So I kind of just transform this into an object, a list of objects with a type of key, where the key is position, rotation, or scaling, and then the value is one of these arrays. So it makes more sense when you look at the types. This actually dictates all the messages that I've defined so far. So it makes for a pretty nice API, because if you want to know, hey, what can you do in your space? All you have to do is come to this file and you could look, these are all the things that you can do. You can say that somebody entered. You can say that somebody's observing. You could say that somebody moved. And in each one of these cases, it has just enough payload to describe what's going on. So in member entered, you want to say, okay, what's the member ID of the person who entered, and where did they enter at, right? So here's the position and rotation of the person, and that's all you need. The timestamp is kind of optional. It's just like, okay, when did this happen? So it's milliseconds since epoch, aka Unix timestamp with milliseconds, that you can easily create in JavaScript. Member observed is like member entered, except it's a cheaper way because we don't have to broadcast its position. It's like I'm secretly in the room, but nobody else can see me, but I can see everybody else. But it saves computing power because you don't have to forward my position to everybody else. Member moved, here's the member ID and then the new position they're at. Member left, you don't need the position rotation, you can just delete them. So here's the member ID. Entity created, we already went over, so is the type, the ID, the name, and the components. Transform means you're moving it, and you can optionally move the position or rotate it or scale it, so you're transforming it somehow. So you're just saying entity transformed with the entity ID and any one of these things that you want to change. So components is a type of one of these things, but typically when you transform, you only transform position, rotation, and scaling. Finally, we have a special one for if you want to change the color, entity colored and entity deleted. So pretty nice API. And what I've done is I've hooked up to create this kind of, so this is the type, and in the primitives, in the callback, I'm creating the event. So here I'm filling it in with data. So then this, I'm emitting it to, so this is outgoing, I'm emitting it to signal hub. So this is signal hub outgoing emit event, and then the entity, the actual payload here. So this doesn't go anywhere. This just goes into this event bus called outgoing. But Space Broker is listening on outgoing. So it's listening on the outgoing. So on event, push it to space channel. And this is when it leaves the front end to go to the back end. So this is when we go from here to here. Following me? Now, you still there? Okay. Yeah, your audio is breaking up. But okay, space channel is going to handle that event. So when you forward it, you go space channel push event, you create a handle in event, and here's the payload. And then we're just delegating that to something called space server process event. So let's go to space server. So space, okay. Oh, let's put a note over space channel, and we're gonna handle in event payload dot dot dot, and then we're going to go from space channel to space server, and we're going to say process event. So this, we're calling a function on process event. Now remember, space server is a gen server, so it needs the slug to determine, it's using the Elixir registry to find out which process it is. It's sending the payload, and it's also sending its own PID. The reason why you're sending the old PID is because you can use broadcast from, which means that in most cases you can send the message to everyone except yourself, because I wanted the client to react faster. So if you make a round trip with the server and you wait for that round trip, then it's going to be slow when let's say we shoot somebody. We want that person to be immediately playing the animation, because I'm the one that fired the gun. I want to hear that sound immediately. I want to see that bullet fly immediately. So if I have to wait for the server to tell me that might be 250 milliseconds later. So I chose to send the PID so I can use the broadcast from API so that I don't receive my own event. I'll just play my own event immediately. So what does this process event do? Process event, this is the external API, and internally we'll do gen server cast. So this is typical gen server API. So we need to have a cast, handle cast, for the event. So we go down to handle cast, and here's the event, and here's the payload. And then this gen server is holding on to an internal state called sequence. So we bump up the sequence number by 1, and then we create a map of attributes, and we'll store this in the database. So what happens here is that we're taking this payload here, and we're kind of storing that in Postgres, and these are the attributes of that record. So now you see there's a space ID, there's the type, there's a sequence number, there's a payload, there's a timestamp, and we're storing this. But because gen server handles one message at a time, I didn't want it to do the writing in here, so I actually deferred it, and I was trying something out called gen stage. So I forward this to another broadcaster. So I take this and I stuff it in here and allow this thing to do it. So we have this thing called a QBroadcaster. So let's go from space server to QBroadcaster, and here we just have it called async notify. And then here, so we don't have to wait for it to write to the database, because maybe writing to the database is slower, and we don't actually care how often it writes to the database. Just do it at some point. So right now it writes per every message, but it could potentially write every 5 messages or write every 100 milliseconds or something. But here we do a broadcast event and a similar kind of thing. Right now it's broadcasting after every event, but I could see it potentially caching or only broadcasting those events that are close to you. So this API might change. But broadcast event just calls the built-in endpoint broadcast. So there's 2 versions. So if a PID is not given, if we don't have it for some reason, we'll just broadcast to everybody, including ourselves. If we do have the PID, we'll say broadcast from our own PID. That way we ourselves don't get it. Now, a consequence of this is that in the primitives area, if I'm creating something and I want to see it immediately, here I also emit it to myself anyway, because I want to trigger something that's going to draw it. So I do send a message to myself. Here's incoming in the event. So we do have event handlers on the front end as well. So the thing that's listening for the incoming event here is the space manager. Scene manager. Scene manager is listening for all kinds of incoming events. And one of the things it's listening for is entity created. And that allows us to find or create the mesh locally. So if we run the server, okay, some things, oh yeah, I was working on snapshot. Let me comment this guy out because it's still a work in progress. Okay, our server is running. What I'm going to show you is that we're going to visit a space on the left side, open up Firefox on the right side, and the events are going to go flying, but also you're going to see some lines fly by here because it's going to be writing to the database. So I'm going to expand this a bit. So if we go into space A, okay, so this person enters here, this person enters here, and it may be wonky, maybe we only see one of them. Okay, so we see this person over here, and we're generating a bunch of messages because now we're storing every member moved. And if you look at this, it's insert into event streams, and you're getting all this data, the timestamp, the member ID, here's the member ID, the position, posrot, which is the position as an array, rotation as a what do you call, quaternion.
What?
A quaternion is a vector 4. And where's our... So this is the 619th sequence. This is 620 sequence. And so...
Just like for right now.
Right,
Oh,
yeah.
no.
So for me, going around, just turning the face around like this and kind of moving that around, we come back here, the sequence is 654 right now. So generated like, I don't know, 40 some messages.
Wait, where's all this stuff being stored in, like, Postgres or something?
Yeah, Postgres.
Okay, cool.
So, and then this still works. So you come over here, and like I said, the primitives are here. So I can create a grid, and it's broadcasting the message over here. So I can still create the box. Right? I can create the sphere. I can still go into transform mode. Let me move. Oh wait, transform mode. Gotta move over here. Oh, that's moving the plane. Let me get over. So you see the sphere underneath it. So the movements are still being kept, right? The movement, but I'm storing every one of this. So when you move the box, it's actually going to come in here. Let's see. This one is component. What is this called? Entity transform, right? So here's an entity transform. Now the problem with this is that if you close the space, see there's a grid and a sphere and a cube, a box, right? But if I close this, or even if I just refresh this, it's all gone. Because we're only broadcasting the streaming data. We don't have the previous state entirely loaded because we have hundreds of messages, and we actually only need the 4 entities, the grid, the sphere, the cube, or the box to be present here. So I'm working on the snapshot. So what we have here is, let's see.
Wait, in the past, have we ever been able to reload our old spaces?
Yeah,
So that's what you're talking about, right? For
yeah,
now, you
yeah,
want to reload the previous snapshot or something,
yeah,
save state.
yeah.
Okay,
We had that ability. We just lost that ability.
that's it. Yeah, it's been a while. Can't remember. Okay, cool.
So let me grab a space ID. So here we do have a method to read the stream. So here is the functions to insert into the database, create event, the query to look up the last max ID, and here's the stream. So you can give a space ID and the starting sequence and how many messages you want to get. So let's call this one. So it's spaces event stream. Here's the space ID. So let's say we start from 0. We get a whole bunch of messages and it goes up to 100. So all of these were in order. You see how the number is increasing. So the first one was probably 1, and hopefully I guess it skipped in this view it skipped them. So we can like start from 100 here. Yeah, and then it probably goes to 200. So my hope is that we can use this thing in the snapshot. So in the snapshot, I'll have a snapshot test. So I'm calling, here in the test, I'm creating a fake space and I'm starting it in the supervisor. And I created some fake events. So these are to mimic what space channel would be receiving. And then so for every event in this list, I'm calling space server process event. Oh, I skipped the channel. I went straight to the gen server because uh, over here, for example, we go through here to here to here. So right now I'm just in my test, I go straight to here. So we're sending it to the space server. And then that thing is delegating through to QBroadcaster, which this thing I didn't finish here actually. QBroadcaster is actually something that uses gen stage, as I was talking about. And then this thing gets new messages, so it handles asyncly, and it kind of I copied this code from somewhere, so I don't entirely understand it, but I think it queues the message as long as there's some pending demand. But you can subscribe to this. So I have something called a writer, an event writer. So the event writer is subscribed to the broadcaster. Here it is. It subscribes to QBroadcaster. So we have an event writer. So this thing will receive event, handle event, and then this is the thing that calls create event. So this actually writes into the table. So my hope is that this is happening by itself and doesn't interrupt the gen server. So the gen server continues to serve other types of requests, and this thing is mainly about writing it to the database. But right now, when it writes to Postgres, we want to create a snapshot from what's already been written there. And so I go, here's a new method or function that I wrote called update snapshot. and it should handle the first 100 messages. So if you look at update snapshot, what this does is get the event stream, which is this thing down here, and for every one of those, call process, and process is going to be multiple function heads. So it can process an entity created message, which underneath the hood will create the change set, and it will create the entity and the components. So in my one test, it has entity created here, and if you then call serialize the space, this will demonstrate that it has the correct snapshot. So here it has a list of entities, ID, no parent, name, type, box, components. So yeah, this was creating a box. And it has 3 components, position, rotation, scaling. So here's the components for position, rotation, and scaling. And it has a little bit more than that based on what serialize does. But this was what the front end was using. So, but because it's not the front end, we're not using the snapshot yet. That's why when we reload the space, we don't have anything. So we need to fill out more events, because right now it only handles entity created, which actually might be good enough. If we can find a way to, we need to find a place to call the snapshot though. So I haven't figured that part out yet.
Okay.
So where should we call this guy? So right now we're doing this, async notify. So after async notify, we're actually broadcasting back to the channel. So that's happening. And so we want to just store the snapshot. So where should we do this? I guess for now we could do it in the EventWriter. So we'll just handle every single event like it is a like it's processing them. Although that's a little bit tricky because my handle stream wants to handle multiple of these things. Let me see. Here's the event writer. The event it's creating is what shape? It's this shape. This is the event that's being sent. And so that's a little bit different than what the snapshot takes, because the snapshot is taking the queried result, which for example doesn't give back space ID. It doesn't give back sequence. It gives back this. You could write to it. What happens if we just want 144? Okay, let's or just get 1 and give me 1 back. They'll give you back the message after that. What if you're off the array? What if you ask for like -3 and there's nothing to get back? Select where space ID and sequence is greater than. Limit order by this sequence. Okay. I guess we can cheat a little bit. So we can do VXR snapshot process. So we need a kind of modified event. It's not really modified, but let's see. Oh, I don't have the space ID. I don't have the space ID. Oh, I can get it from the event. Event space ID. In fact, I could just create this for space channel snapshot process. Snapshot wants something that looks like, okay, looks like this. Payload sequence type. So I guess we don't need this. Event dot what? Event timestamp. Event underscore timestamp. Okay, the incoming payload for event is this. The outgoing payload. Okay, so we can keep this. We can keep payload, I think. We can keep sequence. We can keep type. Oh, everything's the same except it has an extra space ID, right? Type, sequence, payload, event timestamp. It just has this extra space ID. So I don't think we have to do anything. Let's just send it along. I think we can just send it along. Oh, what does it need? Oh, it needs the space ID. Oh crap. Process space ID, entity created, and the payload. create event space ID event space ID event type and event. Okay. Okay, let's see what happens. So we'll just mix ecto reset, clears the database, start the server. So now I'm going to go create a new space. So A, edit that slug. Now we're going to enter it. And I'm going to create a grid. Let's see, grid box. Let's take a look at what I did. Insert into components. That's a good sign because this is the snapshot. Insert into entities, insert into event streams. So we're getting a couple of components, an entity. Looks like it's working, at least for the creation. So if we refresh this, it may not work because we haven't handled the new version of the snapshot. Let's give it a try. So if we refresh this, oh, it's there. Well, what do you know? It works there. So if we go to Firefox,
Nice.
so that works. It's a pleasant surprise. So the reason why that works is because let's trace through this. So if we do what is our, we have to grab an ID, so let's just go to the edit here to see what the space ID is. So we have this function called spaces serialize, and it takes an ID. Or was it a slug? Is it a slug? Let me look it up. Spaces serialize space. Oh, it needs the whole space. Okay, so repo, or actually spaces get what? Get space by slug. And assign this to a space. So this is what we return in terms of the cache. This is what the snapshot makes available for us. And when we're loading the space from the space controller, we just call show HTML. Here's the HTML for a space. We set window serialized space is raw, serialize the space. And the front end is making use of the serialized space. Inside orchestrator, it passes it into orchestrator and passes that into scene manager when it's created. And ultimately, when it says the entities, it loads the entities, and then it's going to do something with that, right? So what uses this entities? Here we go, parse initial scene. So the scene manager, when it creates the scene, it'll parse the initial scene, which will go through every entity, and it will find or create the mesh. So find or create the mesh will, in the scene, look for mesh by entity ID. ID is this auto or the UUIDs that we generated when we're creating these things. If there's not a mesh, go and create it by the type. So box will call the Babylon interface for creating a box. Plane will create a plane. Grid will create a this and that. So this is all code we had before. It will create it, and then it will go and cycle through entity.components for each one. So there's a components key on each one of these entities, which describes the position, rotation, etc. And so process component expects a component to be of type and data. So it has a type key and a data key, which is exactly what's here. Type, position, data is whatever. So if it's position, it will set this. And so, okay, so all of this is ready to get hooked up. In fact, let's see if we can change a color. Oh, change of color won't work because we are not setting a component. So we have to fill out more of these entities. So here's the problem now is if we go here and we want to move something, if I click on this and I move it, we have saved the event, but we haven't updated the component. So even though I can kind of like do all this stuff, I can rotate it, move over here. When I refresh this, it should go back to the origin. Yeah, so that didn't persist because our snapshot handler only processes one thing, which is entity created. And we've got a couple more to implement here, right? So we need to handle not just entity created, we need at least these two to handle when you've transformed, when you've colored it, and when you've deleted it. Otherwise, the snapshot stays where it's at. So, but anyway, I've given you a broad overview, bringing you all the way from the work I did off when you guys weren't around to bring it up to event sourcing, and now we're up to creating the projection. So I was in the middle of creating the next function, which is called entitytransformed. So here's the thing I was working on. So we're going to get a payload. Here's pattern matching, some entity ID and a component. And I wanted to be able to save all of these at once into the database. So there's this thing called multi-new where you can, I think, add multiple statements into it, and then we'll execute it as a transaction. So we wanted to reduce over these, which means that you pass in the previous multi and you give back a new multi, ending up with something that you can pipe into a transaction. And so from here, I just didn't know how to write this query. So I think this is the thing that might be messing me up. So I'll comment that out. So the reduce takes an enumerable, so we're enumerating over the components, and then a function. And the function takes, I can't remember the order. Is it the previous and then, like, does the accumulator come before or does the iterator come before? I need to check. Let's do some Googling.
Accumulator and later.
Accumulator comes after?
You mean is the accumulator is like the accumulator is the one on the right. Yeah. Yes.
So this is previous multi, and then the initial state of the accumulator comes out here, right?
Yeah.
Okay. So then here, what I'm going to do is I compose some kind of query, and then I do multi. So the return value of this function should be the new accumulator, which is multi update all. So it should return a new, adds an update all operation to the multi, and it returns a new multi, right? Yeah, I think so. So I wanted to basically copy what she has here. Multi update all. Oh, but this is piping some other thing into it, I think. Yeah, it's piping this case. So it takes the multi, and then it takes some kind of symbol, I guess, and then a query. Okay, so first let's build the query. So I think it's query from C in components. Do you know how to write this? I'm rusty at this. Let's see, ecto update.
I don't know anything about ecto.
From PPP. Okay, so I think I want from. From is a function. So from C in components. Start with that. Where so this is a select. Update all. Okay, so I don't need a select, I need a where. So where yeah, C entity ID is equal to the entity ID from above that we destructured. So we're entity ID and C.type is equal to this component, and it's going to have a type key. So that's the thing I want to update. And what do I want to update about it? So now we go update and set this to this. So hopefully I can do this. So we want to comma, paste, update, set, type and data.
You're reduced. You don't have a accumulator.
The accumulator, the accumulator is here.
Where?
Here.
Where? I don't see anything.
Huh?
Where are you pointing with your mouse?
Yeah.
I don't see it.
Can you hear?
Oh, yeah, but no, the initial value of the accumulator
is here.
Wait, let me see.
Line 51.
Doesn't the accumulator have to be before the function?
Does it? Okay, let's check. So elixir enum reduce. I get confused because JavaScript does it some way and then, okay, reduce. enumerable, and then function, enumerable, accumulator. Oh, okay. Okay. Yeah, this is different than JavaScript. Okay, so you have the enumerator, the accumulator, and then enumerator, accumulator in the function. Got it. Okay. So we're going to want this. In other words, you want the function last, right? So enumerator, accumulator. Whoops.
The multi, right?
Yeah.
Okay.
Followed by enumerator and then the accumulator. Got it. And then this thing wants to set the new data to be component because it's a map. And so you should be able to take it. So that's the query. Then we send this query in here. I don't know if this needs to be a symbol, but okay, what's going on here? Unbound variable component in query. If you are, in the XR spaces component. Actually, in components, it's the table. Maybe that. Okay, they all took an atom here. Okay, so the XR spaces component. I think it might be okay. It's still executing. Oh no, unbound variable component. Uh, isn't that here? Component. Oh, here.
Okay, cool.
There we go. There we go.
Oh, wait, what just happened?
It needed to, this kind of pattern matching, so you have to put this caret over here.
Oh,
And then
okay.
what's happening here? What's this underlying for? Call to missing or unexported function. Update all three. Update all three is undefined or private. You need update all four. Takes the multi. What is this, a function? I think it just has some arguments here. Okay. Alright, let's see if that does anything. So let's add that to our test then. Snapshot test, entity created. We'll add a new message for when entity is, let's go ahead and get space by select. No, get, oh yeah, we have space ID. Nope. Okay, I want to get the stream. So spaces, event stream, space ID, probably I can get the last one. So the last one was member entered, entity transformed. Okay, so this looks like a, whoops. Ooh. Copy. This here. Okay, so it's a little bit different. This is just some timestamp. We have some payload P. With some components, which is type rotation, and then I guess the ID is the box that's moving. So we'll just move the box. We use the same entity ID. And let's make this easier. We'll just say that this is 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we'll remove this one. So the rotation it came in with was 2, 3, 5. When we process this, we expect that when we call the serialize, it should have a different rotation. So if we call mix test, bam, exploded. Handle cast event. Oh, the sequence is not right? Sequence. Oh, we don't want a sequence. Also, where's the type? That's the M, that's the message. Explosion again. Let's see. Change that has not defined by any constraint. Constraint error when attempting to insert struct. Snapshot line 10. Okay. Constraint error, like a subdomain. Code, ecto, uposchema, constraint errors, this map. Maybe we can inspect the multi. So we can go to snapshot and before you call the transaction, what is this? IO inspect. Let's see if it gets to this part. Label multi. So maybe we didn't get to this part. Right? We didn't get to the output. What's the query? Let's try mix ecto reset the um, mix env test environment. Just make sure we have a blank database there. Entity created. Is it this thing that's causing the error though? Let's comment this guy out. No, it's not even this thing. So something else happened. Process event. Well, we could take a break. It's already a little bit over. Were you following, or was this putting you to sleep?